So one of the first programs we do is I encourage the kids to build a snowman. The basic idea is they need to bring over some spheres. Now I'm not using the mouse like we would have taught them, but they very quickly they bring over a couple of spheres and they stack a snowman just like this. And to them, from this perspective, it looks like a snowman. The experiences they've had are either real world or two-dimensional on the screen, right?
Yeah.
Nothing's moving here. It's not a video game. They don't realize that if they rotate the canvas, nothing's connected. And if they rotate the canvas, they're not actually standing up. And my whole goal at the beginning is just to say, okay, we're experimenting. We're learning through exploration. Figure out how to do this. I've told you that the left mouse button is the doing mouse button, the right mouse button is the looking mouse button, and we've just looked at it and you've realized there's a problem. Now I'm going to get you to figure out the next step.
Right.
They hum and they haw, and I say, okay, well, what happens if you click? And some kids get it right away, and some kids are very exploratory and they go into it immediately. Whereas some other kids are like, you haven't told me what to do, so I can't do it. And that's sort of what the mold we're trying to break here is, no, you can learn this on your own. So what I'll say is, well, you notice there's some shadows underneath those things. How do we make those shadows move? And I don't know, if I look at it different angles, the shadows kind of move. Is that what you mean? No, it's not what I mean. I say, what's that little triangle on top? What happens if you click it and hold it and pick it up? Oh, well, then it's blocking my other one. It's not a snowman anymore. I said, oh, but it's in the air finally. Oh, that's cool. And then they'll move it and they'll put it like that. Yeah, great. Oh, but it's still not really where I wanted it. How can you figure out where it's supposed to be? Well, you can figure out where it's supposed to be by overlapping the shadows, right? The sun's coming down from on high. And they don't get it perfect, but very quickly they decide that they can do this. They haven't noticed things like the measurement of height off of the plane, off of the working plane. But yeah, I've got a snowman. Oh, I want that. I'm going to move that down a little bit. Oh, look, that's cool how they connect. Interesting. Okay, I've got a snowman. He's leaning a bit, but I'm not worried about that. Okay, I'm done. Okay, we'll put some eyes and some nose on it and stuff. Or they'll connect them together lying down, and I'll show them how to group something and rotate it from lying down to standing up.
Yeah.
And they'll just very quickly get some experience. It doesn't take very long for them to get into the, oh, what other shapes can I do? And then we've got castles.
Yeah.
And we got crazy things. So it's very basic.
Yeah.
It's very simple. They're already familiar with the basic shapes.
Right.
We're not trying to get them to use multiple shapes. It's just done.
Very cool.
And they've had to go through the experience of lifting things off the plane, looking at it in 3 dimensions, connecting them up, and figuring out how to align them in 3 dimensions on a two-dimensional representation.
Yeah.
So TinkerCad is phenomenal for this kind of thing. It's not nearly powerful enough for a lot of probably what your viewers and listeners are interested in, but it's a fantastic introduction for a 5-year-old or a 12-year-old or their parents. It's a perfect beginning place. So this is one of the designs that one of the kids came up with at one of our recent things. And they were just playing with the basic shapes that are available in the TinkerCad library. There's a whole bunch of extras that are available for playing with here. And they go to town on that. And they don't think about bridging. They don't think about support. So printing it's going to be a bit of a challenge. But sometimes they're not thinking about the printing. Sometimes they're just thinking about, oh, this is so cool. I can design something like I see in a video game. Right? And sometimes they get really creative, and they're working with basic geometric shapes. But in this case, they've designed a cat out of cubes. And it's just phenomenal what they come up with to solve the problem. And they were really actually upset when they got to the end of this that they wanted to keep going. So, so really kind of interesting things that they come up with. And sometimes they leave stuff hanging out off the plane. They don't realize how easy it is. This is probably their first try at the snowman challenge. Right?
Yeah. Wow.
So, and sometimes the kids come up with these really cool designs. Like, it's not quite perfect. You can see that the roof isn't quite attached to the building there. But this was a child somewhere in the age between 5 and 12, probably closer to 12, who had never experienced 3D modeling before, who'd never talked about 3D printing before, and got through the snowman challenge and got to the point where they're designing trees out of boxes.
It's very architectural.
Within the first 90-ish minutes.
Yeah.
Right? So this is definitely not a hard technology to grasp, and we want as many people as possible to see this kind of thing and realize that this is possible. And usually where I leave the classes off is with the question, so you've now seen the technology, you know how to use a modeling program.
Right.
You know how a 3D printer operates.
Yeah.
In some cases, you've experienced 3D scanning with our Connect setup. How are you going to go and change the world with this? What are you going to do? And I leave that sort of open-ended question. Some of the kids put their hand up right away. Sometimes we get into a big, long discussion. Sometimes they just sort of leave thoughtful
right.
At the end of it. But I'm not going to tell them what to do with this. I'm just going to tell them that this is possible.
Right.
And there's a whole new tool that they can put in their toolkit for creativity. And I get calls after the fact all the time from parents and teachers like, oh, did you know that Sally did this or Karen did that, and they wrote an essay on how they might help third world countries after a flood or
Wow.
something like that. And I'm like, yeah, did you know? And then I point them to the articles about like the concrete printers where they're printing houses and get into an exchange, like a pen pal kind of exchange with these kids and their teachers, just keeping the excitement and the momentum going, right?
Very cool.
So yeah, we 3D printing, modeling, and scanning is one of our most popular programs. I am going to say because rockets and electrified artwork are technically more popular in terms of sales.
Yeah.
But all of them are hands-on and fabrication experiences that lead the kids to get out of their comfort zone or remember their comfort zone in some cases, get back to the I can rather than I haven't been told how yet.
Right. Yeah, it's the power of possible.
Exactly.
That's the beauty of it.
That's a great way to say it.
Yeah, very cool.
So yeah, is there anything more I can show you? Anything to tell you about our programs?
I think that this was fantastic.
Okay.
I think our viewers are really going to enjoy, and thank you so much, Cam.
Thank you very much. Take care.